Hi everybody, welcome to our next video, and today we are going to discuss something regarding LTE capacity optimization. And one of the salient features of LTE and LTE advanced is carrier aggregation, and today we are going to discuss carrier aggregation. And also just to let you know, in the end of this video we are going today going to make an important announcement regarding our videos and how we are going to take this forward. So please stay tuned and watch the video till the end. Thanks for that. So let's begin our video on carrier aggregation. Carrier aggregation is basically a technology aspect in LTE and in LTE advanced, where you can combine two RF carriers to provide more throughput to the mobile in question. For example, you have one 5 megahertz RF carrier in 900 megahertz band, and you have one 10 megahertz carrier in 21 megahertz band, or in 1800, or in whatever is the case. So what you can do is basically combine the resources from these two carriers and provide extra throughput to your mobile station. So your mobile will be receiving bandwidth from two carriers instead of just the one carrier which the primary cell belongs to. You can basically add two component carriers. You can add 3, 4, up till 5, and if the bandwidth provided by one component carrier is 20 megahertz, in total you can provide 100 megahertz of bandwidth to a particular mobile station and to a particular cell coverage area. So in this video we will go through the basics of carrier aggregation, and also the most important deployment strategies, where you can, how you want to deploy carrier aggregation in order to achieve certain aspects in the network. So let's begin with the basics. The basics, first of all, is the primary cell. Whenever you are aggregating or combining carriers, they are called component carriers. For example, if you are aggregating a 1 5 megahertz carrier from your L700 and you are combining it with another carrier from L700, then each of these will be called a component carrier. So if you are aggregating two, then you will be saying that you are aggregating two component carriers for your particular configuration. Then in terms of primary cell, there will be one primary cell through which all the NAS, non-access stratum communication, is carried out. All the verification, ciphering and everything else is carried out. That will be your primary cell, and your primary cell will also be responsible for your handover and other mobility aspects. Then is your secondary cell. Secondary cell will be basically providing another component carrier, and it will be just there to provide additional capacity. It will not be providing any non-access stratum services additional to the primary cell. So the secondary cell will just be there to provide capacity in forms of another component carrier. And if you want to add another one, so there will be another secondary cell. So if you have, for example, 3 component carriers aggregated, then you will have one primary cell and then 2 secondary cells. If you have 4, then you will have one primary cell and then 3 secondary cells. In terms of aggregating the bands, we have different you can say types. For example, you in LTE you have contagious and non-contagious bands. For example, the bands which are located close to each other, or the bands which are located separated from each other. For example, this is your frequency. One band is here and the other band is here. So these are non-contagious, and if their bands are close to each other, these are called contagious band. So within the same band, we can have intra-band contagious aggregation and intra-band non-contagious aggregation. And then the third type is interband carrier aggregation. For interband, for example, we are aggregating 700 and 1800, that is your interband carrier aggregation. And if we are aggregating to 5 megahertz band of the same 900 megahertz frequency, then that is called your intra band, and that can be contagious and non-contagious. All of these are already implemented in LTE, and there should be no problem in terms of performance. Number 4 is your max CCs, that is your maximum amount of component carriers. So we can have maximum 5 component carriers in LTE, and that gives you a maximum bandwidth of 100 megahertz, and that is in your LTE advanced specifications. Then we have in both uplink and downlink, carrier aggregation can be done both in uplink and downlink, but you need to remember one point, that always the component carriers in downlink are greater than the component carriers in uplink. And then UE category. UE category is an extremely important concept in terms of carrier aggregation, because not all of the UEs are capable for carrier aggregation. And when the UE sends the attach request message to your particular network, then it provides the information regarding the carrier aggregation capability, and there are certain types of combinations of bandwidth carrier aggregation that are possible and that are provided. That information is exchanged between the network and the UE, and then accordingly the carrier aggregation features are provided to the particular UE. We have different categories of UEs, and you can search that out in Google, and that can provide you a particular information about the you can say the configuration of a particular UE. Then the most important part in carrier aggregation, which will impact your capacity optimization, is the deployment strategies. How do you deploy carrier aggregation in your network? The first strategy, we may call it strategy number 1, is basically your intra-band deployment. For example, you have 2 carriers, both of them belong to 1800 megahertz, and you deploy them basically in an overlay manner. For example, this is your base station. These two are your, we'll select these 2 base stations, and then you have your bands from the same bandwidth, 2 carriers from the same bandwidth, and you have overlaid them. So this is your first band, and then this is your so you can see that their coverage is almost similar. They're basically overlaying each other, and you have frequency F1 and frequency F2. So they are overlaying each other, and basically the concept of the second component carrier is for capacity. The coverage is provided by your F1, which is this one, which has slightly more coverage than your F2, but the whole concept is just to provide capacity, and both of the component carriers almost share the same coverage characteristics, because they are from the same band. They can be from 700 megahertz, they can be from 18 megahertz, but both of them belong to the same band. The second strategy is that you basically use the interband carrier aggregation, and in the interband carrier aggregation you can have a strategy like this. This is your basically F2, and F2 is greater than F1. So F1 will provide your coverage layer, and F1 will also provide will work as the primary cell and will handle all the mobility and other aspects, and F2 will basically provide you the capacity part. But if you can see that it's still not you can say targeting areas like hotspot, but it's basically providing a part of the cell coverage in terms of your whole coverage area. Then the third strategy is basically again your interband carrier aggregation, but in this you just cover the hotspots near the cell, and this is your bigger coverage area. So this is another strategy where of course again your F2 might be your L26 band, your L21 band, or your L23 TDD band, and your F1 is basically your coverage layer. So this whole thing is basically used to you can say target your hotspot areas to provide extensive capacity, and in that case usually this will be through an RRU. So you can have an RRU here, you can have an RRU here, you can have an RRU here, you can have an RRU here. So you're aggregating. So here in this area, these belongs to F2. So in these areas where the hotspots are and you are covering them through the radio remote unit, you can aggregate F1 and F2. But in the rest of the areas where there are no hotspots, there is only coverage provided by F1. So basically in your hotspots you optimize, you increase your throughput via carrier aggregation, and in the rest of the areas you do not do any carrier aggregation and you do not provide coverage through your RRUs. So this is another deployment strategy. And another deployment strategy is when you basically what you do is, this is the coverage area of your F2 layer and this is the coverage area of your F1 layer. What you can see is that if this is a cell edge, you are using a particular component carrier to provide coverage on the cell edge areas. Your main primary coverage is in this direction, but you are providing your component carrier to provide increased capacity in your cell coverage area, cell edge areas. So in order to improve throughput, in order to improve your capacity on the cell edge areas, you direct the beam or you direct your azimuth from the secondary component carrier towards the cell edges as compared to the other cell, and therefore you can use carrier aggregation actually to improve performance on the cell edge areas. And the fifth strategy can be used via using relays, where you provide the relay based coverage to enhance the coverage of one of the component carriers. So this is how you deploy carrier aggregation and how you optimize coverage and capacity through carrier aggregation. And one thing to remember very clearly is that you always need to ensure that you provide component carrier and carrier aggregation in good SANR conditions. Otherwise you will be wasting your resources because as far as LTE and wireless concepts, when your SNR is below a certain threshold, you can give as much as resources to the mobile, but it will not provide the required capacity. So I hope you liked the video, and the important announcement that we wanted to make is that we will be gradually moving away from the Facebook groups, and we will probably be using this YouTube channel as the main source of our videos. So we would like, if you like our videos and if you watch them through our shares on the Facebook group, please do subscribe to our channel, our YouTube channel. You can, if you watch it on your mobile, you can sign into your Gmail account, subscribe to us on the YouTube, and push the bell icon as well so that you get notified. This is very important going forward, and we would like to see your feedback, see your comments, and if you like the video, please do like it on YouTube. Thank you so much, and see you next time in our next video. Thank you.